Hello everyone, welcome to Young Innovators. In our previous video, we had learned about the basics and working of 555 timer. In this video, we shall build few interesting circuits using 555 timer and analyze the output. Let us build our first circuit now. We are on the Tinkercad workspace. Our first circuit is on flashing the LED using a 555 timer. Hope you have noticed the circuit diagram and have noted it down. You can try the circuit on your own. The components needed are a breadboard, 555 timer, a 5-volt battery, 3 resistors of 1 kilo ohm, 10 kilo ohm and 100 kilo ohms each. We will drag the resistors from the component list and change the values as needed. An LED and a polarized capacitor of 1 microfarad value. We have all the components placed on the workspace. Now let us make the connections on the breadboard using them. We will place the IC as per our requirement. We will short pin number 4 and pin number 8, and in the same way pin number 2 and pin number 6, and then connect the terminals of the battery to the power leads on the breadboard. Connect the positive terminal of the battery to the 10 kilo ohm resistor, and from the other end of the resistor connect it to pin number 7. Now from the terminal where we have connected the power to the resistor, let us connect to pin number 4. And from the terminal that we have connected to pin number 7, we will connect it to pin number 6 with a 100 kilo ohm resistor in between. From pin number 2 of the IC, we will connect it to the positive end of the polarized capacitor, and from the other end we will connect it to pin number 1. From the negative terminal of the battery we will connect it to pin number 1. Now the remaining pin is only the output pin, that is pin number 3. Let us give the pin number 3 to the LED through 1 kilo ohm resistor. That is, the anode will be connected to 1 kilo ohm resistor and the 1 kilo ohm resistor will be connected to pin number 3. And the other end of the LED, that is the cathode terminal of the LED, will go to the negative terminal of the battery. This completes the circuit. Now, on clicking Start Simulation, you can see the LED blinking. If you have observed, in the previous video, we had told that 555 timer works in different modes. And here it is working in an astable mode, where the output is seen at a particular time, which generates the output. The rate of blinking of the LED depends on the capacitor value. We can change the capacitor value to vary the blink speed of the LED. Next, let us see the circuit where there are 3 LEDs connected to the output, and let us change the capacitor value and see the change or see the variation in the blink speed of the LED. The circuit diagram is as shown. If we compare it with the previous circuit, there are few components added. That is, there are 2 polarized capacitors used and 3 LEDs are taken at the output. Let us connect the same in the circuit and see the variation in the output. We are back on the workspace here. Let us take the components that we need extra for the circuit, that is, again a polarized capacitor and two LEDs. We will change the color of the LED for our reference. Now, retaining the connection of 10 kilo ohm and 100 kilo ohm resistors, let us change the connections of the capacitor. We will change the capacitor value to 10 microfarad and connect the positive terminal of the capacitor 1 to pin number 2 and the negative terminal to the battery negative. And in the same way, let us connect the pin number 5 of the IC to positive end of the capacitor 2 and the negative terminal of the capacitor will be given to negative terminal of the battery or pin number 1. Here we give it to the battery negative. From pin number 1, we will give it back to the battery negative terminal. We will place all the LEDs together, and lastly, all the cathode terminals of the LED will be shorted and given to the negative end of the battery. And from the pin number 3, we will give the connection to the anodes of the LED with a 1 kilo ohm resistor in between. On completing the circuit and starting the simulation of the circuit, all the 3 LEDs glow and start blinking. But the speed of the blink or the rate at which the LED blinks is reduced and it is very slow. This is because the value of the capacitor is changed. Now, let us change the capacitor value to 0.5 microfarad and the blink rate of the LEDs are too high as the capacitor value is decreased. From these circuits, we understand the working of the 555 timer in astable mode and how the rate of blink can be varied when we increase or decrease the capacitor value. Having known this, can you guys think and list some applications where we can see 555 timer? Hope to see you in the next video. Thank you for watching.